Hello students. So in this session we are going to discuss about the previous year questions this year 2024 in JEE Main on this chapter gravitation. Okay. So let's start with the first question. A metal wire of uniform mass density having length L and mass m is bent into a semicircular arc. So suppose there is a wire of length L and its mass is m. It's bent like this semicircle. Okay. And the particle of mass m is placed at the center. So the particle of m we keep at the center of the arc. The gravitation force on the particle by the wire is, so what is the force they are asking? So it's a uniform mass distribution, right? If you take this distribution of mass of the wire is uniform along the length. Okay. So in such case what we do, this we have to take a small element whose length is dl. So its corresponding mass, right, will be, let us say, d of capital M, which will be lambda into dl, right? And this small angle, that is d theta, and its angular position will be theta on x-axis. So this small mass dm is lambda dl, and dl is equal to r d theta. R is the radius. Okay, right? So we got this mass. Now we'll calculate force on this small element. So definitely the force is towards, it's attractive force. This angle is theta, so we can resolve this force into two components, and this force is a small force, so df we will write, so df cos theta and df sin theta, right? So when you resolve this force, these are the small forces, so you can resolve for each such elements, and then you have to add, that means integrate it. So while you will be integrating, you will see that the x component will get cancelled out. So total component of force must be x-axis df cos theta and y-axis component df sin theta, right? This you have to integrate, and from where to where the angle is going? Angle is going from 0 to pi, 0 to pi, because it's a semicircle, right? So cos theta integration will give sin theta, because lambda r is constant here. When you will write, what is this df first of all? So df is equal to g small m d capital M by r square. So when you substitute d capital M, that is lambda r d theta by r square. So after you substitute it, one r got cancelled, so g m lambda by r d theta, right? So when you will be substituting this in the calculation of fx, df cos theta, so g m lambda by r comes out, and you have to do cos theta integration d theta going from 0 to pi. Same way f of y, you have to do g m lambda by r integration of sin theta d theta, right? 0 to pi. Now let's do it. So definitely cos integration will be sin, isn't it? Cos integration is sin, and you have to integrate it from 0 to pi, and you know that sin pi is 0 and sin 0 is 0. Both are 0 0, so this becomes 0. That's what I was telling, that they will cancel out. Now along the y-axis, sin becomes minus cos gmm lambda by minus cos theta 0 to 1. So cos of pi is minus 1, so minus will give us 1, and Again minus minus plus cos 0 will give extra 1, right? So this you can integrate gm lambda by r. So plus 1 plus 1. So that will come as 2g m lambda by r. Now let us substitute that 2gm lambda is total mass by length. A radius is what? Radius is what? Because that length has converted into pi r, right? So radius you can write as L by pi. So L by pi you write. So what do you get? The net force is only along y axis, and this is 2 pi g small m capital M by L square. So finally we can see that this is what we are getting, isn't it? Let us choose the option 2 pi g capital M small m L square, right? Option number 4. Okay, so such type of questions are also coming in JEE Main, where you have to derive a little bit and then you can do that. Okay, let's move to the next question. Next question: a 90 kg body placed at a distance of 2r from surface of Earth experiences gravitational pull off. So we know G is equal to gm by r square. Now they are saying that from the surface of Earth this height is 2r and this radius is r, right? So in general this is at the surface of Earth, which they have given as 10, but in general G is gm by r square, where r is the distance from the center, isn't it? For outside point, for r greater than equal to r, we use this formula. So now we can use this here. We are asking the force. So m into g only we have to calculate. So gravitational force or weight is equal to m into g. So mass is 90 kg. This g becomes gm by total distance. Here r becomes 3r, right? Height plus radius. So 3r whole square. So you will see that this becomes 90 gm 9r square. So this get cancelled out, 10 and 9, 90 by 9, and gm by r square, that is the extension due to the surface, so 10 into 10, that becomes 100. Okay, so the final answer is 100, option 1. Now let's go to the next question. Correct formula for height of satellite from Earth's surface. Height of satellite from Earth's surfaces. So here we should know one thing, that Kepler's law, we know T square is proportional to radius cube, right? And when you remove this proportionality, what do you get? And this radius is of course the orbit radius. When you remove this proportionality, what do you get? If you remember this formula, you can use it. Otherwise, if you have forgotten, let us say, then you have to think that time period is 2 pi r by speed, and speed is root under gm by r, right? Gm by r. So if you take, then this will come, and this also has to be written in terms of small g. So this you may write as small g into r, isn't it? Small g into r. But the thing is that here radius of Earth has to come. So let us keep it in this form, right? Time period. So if you square this, so time period square becomes 4 pi square GM R cube. Right? So this relationship you should know that when you remove the proportionality constant is 4 pi squared by GM R cube. So we need to find out. But here of course R is equal to capital R plus height. You should know that this is capital R plus height. So from here R becomes Gm by 4 pi square t square power 1 by 3. Then R you calculate. So height, if you have to calculate, height will be R minus capital R. So that becomes Gm by 4 pi square t square power 1 by 3 minus capital R. Okay. Now we know that acceleration due to gravity at the earth is Gm by R square. I think Gm terms we can substitute it here. Gm becomes small g into R square. Right? So small g into R square t square by 4 pi square power 1 by 3 minus R. This is what is the height, isn't it? So we can calculate height like this. G R square t square. G R square t square by 4 pi square power 1 by 3 minus R. Second option, right? Okay. Let's move to the next. A simple pendulum doing small oscillations at a place of height r above the surface of Earth has time period 4 seconds. Okay, time period they have given at a particular location. That means height is here r. Okay, and Earth's radius is r. So from Earth, the radius of that orbit we know, or this exact radius r we know here, r is equal to 2r, isn't it? At that place time period is given as 4. Next they are saying time period if it is brought to a point which is a height of 2r. Okay, so that means if you change height as 2r, then small r become r plus 2r. That means it will become 3r. That place time period is given as T2. Values they have not given. Okay, so that T2 and T1 relationship we have to calculate. You don't have to calculate exactly what relationship between T1 and T2. T1 and T2 relationship. Okay. So what is the time period? Time period of a simple pendulum is 2 pi root under L by G. And G for outside point is Gm by R square. Right? So if you substitute it here, so this will become 2 pi root under L Gm R square. So that means from here you can see that this R comes out. So this time period is proportional to R, isn't it? Time period is proportional to R. So initially time period T1 is proportional to 2R. And finally time period is proportional to 3R. So directly you can divide it. T2 by T1 is 3 by 2 you'll get. Right? So 2T2 is equal to 3T1. Right? This is the final relationship 2T2 3T1. So option number 4. Here. Let's move to the next question. The hydrogen-like system ratio of Coulombic force and gravitational force between electron and proton is. So definitely this is a fact only that if you take electron and if you take a proton. Gravitational force if you calculate G mass of electron, mass of proton by R square. R is some distance. What about the electrostatic force? Is K charge electron, charge of proton, which is same only. R square. Here the value of K is 9 into 10 to the power 9, and electronic charge 1.6 into 10 power minus 19. Mass of electron is 9.1 into 10 power minus 31. Mass of proton is 1.67 to 10 raised to the power minus 27. Right, other things we know G and K. So if you take the ratio of the Coulombic force, means this electrostatic force, by gravitational force, so you will get that K E into E by G m of electron mass of proton. So this you have to calculate how much it will come. Let us check that. Order of, they are asking order, it means how much powers can come. So okay, let's just rough calculation we can do. This is 1.6 into 10 power minus 19. This is 1.6 into 10 power minus 19 divided by G value 6.67 10 raised to power minus 11. Mass of electron 9.1 10 power minus 31. 1.67 10 raised to power minus 27. So some of the things which can be cancelled here. 9.1 approximately 9 can be cancelled. 1.6 1.67 you can approximately cancel. So this is like 1.6 by 6.67 10 raised to power. Calculate this. Minus 19 minus 19 minus 38. So this is 9 minus 38 plus 11 plus 31 plus 27. How much this comes out to be? 1.6 by 6.67 10 raised to the power. You check. So minus 38 plus 31 minus 7 plus 9 plus 2 plus 11 13 plus 27 40, right? So 110 extra you take here, so this becomes 16 by 6.67 10 power 39. So this will come approximately 2 point something, right? 2 point something will come into 10 raised to the power 39. So now we can see this order is this 10 raised to the power 39. Why this is order? Because we need to express it in terms of some number. This number is less than 10. Okay, it should not be fraction, into 10 power 39. So this 10 power 39 is the order of that. Okay. Anyway, we should know about this as a theoretical concept that is given in textbooks. But anyway, we can calculate and prove also. Right? Let's move next. So there is a match the following type of question here, and we need to match. And before doing matching questions, you just see the options like which thing we can just check. This thing we can check or eliminate. So A is matched with 3 2 1 1. Okay, B is matched. C is the only thing which is matched differently, right? C is the only thing which is matched 1 4 3 2. C you can just calculate. No need to then calculate anything else. Total mechanical. Okay, so let's just check with kinetic energy. Kinetic energy formula we know. Kinetic energy half m v square. Here v is the orbital speed, which is gm by r. Right, v square becomes gm by r. Here what is the r that we have to take? R is the orbit radius you have to take. Okay, orbit radius is a here. This is what is kinetic energy. So kinetic energy is gmm by 2e. So this should match with second. And potential energy minus GMM by again A only. So this will match with this. Total means you have to add both total energy. Mechanical means kinetic plus potential. When you're going to add this plus half minus 1, so minus half will come, right? GMM. So total energy matches with this. Fourth, escape energy. Escape energy, of course, the kinetic energy when you are throwing it. So kinetic energy is half m v escape square. Escape velocity, you know, right? So that is root 2 times 2 gm root under 2 gm, right? 2 gm planet mass, right? Root under 2 gm, the radius of planet. Planet radius is r here. So gm by r, correct? gm by r, half mv square. So escape energy means that mass of the object should also come here. So object mass which you are throwing, that also you have to write. So mass of the particle also we have to bring it. That particle which we are throwing. Particle mass, let's say m dash we have to bring it. Okay. So I think that is missing here. Anyway, so we can select now. We know all this, right? So first is matching with second. That is the only option here. But other thing also you can check. First match with second match with first. C is matching with fourth, and D is matching with third, right? So that's the correct answer. Let's move to the next. A satellite revolving around a planet in a stationary orbit has time period. Mass of planet is 1/4 the mass of Earth. So we are comparing here two planets. So mass is smaller. Suppose this is a planet, and if you take this is Earth. So mass of this planet m dash, let us say, and this is mass of Earth. So this m dash is 1/4 of Earth. Okay. Satellite revolving around a stationary orbit. Stationary orbit means what? Stationary orbit means the time period of this satellite is same as the time period of revolution of this planet, right? So we know the time period is equal to, right? It is proportional to, we know proportion, time period square is proportional to r cube, right? But when we are going to write in terms of equality, therefore pi squared by gm also comes, right? This we should know, because here the mass is going to also affect it. Okay, so what they are saying, the mass of the planet is 1/4, then the radius of orbit of the planet is. Planet's radius of orbit, this r is here, let's say r, and for Earth, radius will be anything, but this is also they are saying geostationary satellite of Earth. That geostationary satellite, that radius they have given, let's say this you take as r dash, this you take as r. Okay. So we can use this t square is, so directly proportionality we can use, so t square is proportional to r cube by mass. This formula we can use two times, one for the planet and another for the Earth. So let us say for earth you are saying, so t square divided by for this uh, t dash square, let us say, is equal to radius for earth by radius for this r dash whole cube divided by mass for earth divided by mass for this planet and dash, right? So what do we want? We want r dash. Okay, so r by r dash whole cube is equal to t by t dash whole square into m by m dash. Let's substitute that values. So r by r dash whole cube is equal to time periods they have given. 6 hours is for this planet. For earth it is 24 hours, we know that. 24 by 6. What is the mass ratios? M dash is m by 4. Right, so this will become 4 m by m dash. So this is becoming 4 square into 4. Okay, so this become 4 cube, right? Okay, so now we can remove the cube root cubes. So r by r dash will become 4. So r dash become r by 4. So for earth the radius of that satellite they have given 4.2 into 10 power 4. 4.2 into 10 to the power 4 by 4. So 1 point something. 1.05 into 10 to the power 4. Correct? That should be the answer. 1.05 10 to the power 4. Yes. Option number 2. Then let's move to the next question. To project a body of mass from Earth's surface to infinity, the required kinetic energy is. Okay, so required kinetic energy you are throwing. So we can throw with any speed, but this is the minimum speed that we should target to throw it, right? We should throw. That is the escape speed that already we know. Escape speed formula. Root under 2g into r. Correct? Now here kinetic energy we have to just calculate. So half m v escape square. So half m square, this means 2g, r will come, 2 got cancelled. So m into g into r. I think here re is the earth radius. Re, this term is earth radius. Okay. Re is the radius of Earth. So here mgr only. So mgr, mgre. Right. That's the correct answer. Let's move to the next. Assuming Earth to be a sphere of uniform mass density, a body weighs 300 Newton on the surface of Earth. So weight is m into g. At the surface of Earth, this is given as 300. Mass does not change, g changes, right? How much will it weigh at r by 4 depth? So at a depth d below the surface of Earth, this depth is r by 4. We know what is g effective. We have to calculate that g effective. So g is g at the surface of Earth, 1 minus d by r. So this becomes 1 minus r by 4. R will get cancelled, 1 by 4. So that will become 3 by 4 of g at the surface of Earth. So weight at that point is m into g effective at that point. So that is 3 by 4 gs. So 3 by 4 mgs. This is the 300 newtons. So 3 by 4 into 300. Just we have to calculate this. Okay, 3 by 4 into 300. How much that will come? 900 by 4. 225. Correct? That's the answer. Let's move to the next question. two planets having masses m1, m2. They are going around circular orbit of radius r1, r2. Angular momentum is given and the ratio of time periods. So we have to establish relationship between these quantities. So if you see the time period square is 4 pi square by g. This is mass of sun, right? Time period square is 4 pi square gm into r cube. This is one thing. Another thing is that angular momentum L is mvr. This is mass of this planet here. That capital mass is mass of sun. So velocity can be written as root under gm by r. Correct? So if you bring everything inside, so gm m square r will come, right? Angular momentum. So if you square this, gm m square r, right? Angular momentum square. Okay. So how can we then establish relationship between the angular momentum square and time period? Radius factor is coming here. Okay, so I think radius factor which is coming here can be completely eliminated, isn't it? So from here radius, if you calculate, it will be gm by 4 pi square t square. Radius cube, so power will be 1 by 3. Okay, so this if I substitute it here in this equation, then L square becomes equal to gm L square into radius, which is gm t square power 4 pi square power 1 by 3. Okay, so now let's count only those things which are important here. L square proportional to m square. Mass of sun, you can leave it t square 1 by 3, 2 by 3, right? This is what it is. So radius got eliminated, I think. Then from here, now if you want, you can take cube of that, otherwise you can keep it. This is the relationship, and we have to get the ratios of time period. So from here, time period power 2 by 3 is L square by m square. So we can say that time period is equal to, now 3 by 2 power you have to give, right? So L by m power cube it will come there, proportional to. Yes, I think this is what we can use it now. So time period of E by time period of B is equal to LA by LB by ME by MB power cube. So what they have given, LA is, for A it is L, for B it is 3. So this is 1 by 3 cube will come, and this is MB by MA power 3. Right? MB means M2 by M1 here. So 1 by 27 M2 by M1 power 3. That's the ratio. Okay. So 1 by 27 M2 by M1. Yes, so that's the correct answer, option number 2. Let's move to the next question. Two satellites A and B go around a planet in circular orbits having radius 4 and r. If the speed of A is 3 v and that of speed of B is. Okay, this is just speed you have to calculate. So root under gm by r. Mass of planet is m, radius is the orbit radius, right? So speed ratio, speed is proportional to 1 by root r. So first case it is 3v is proportional to 1 by root r. First orbit radius is 4r. Next is, let's say, v dash root of r. Take the ratio v dash by 3v. So v dash, that means 1 by root, here root 4, so 2 root r by root r. Root r of r will get cancelled. So v dash becomes 6v. Right? That's the answer. Let's move to the next. An astronaut takes a ball of mass m from Earth to space. He throws. So from Earth surface, a person has taken a ball, and astronaut takes a ball of m from Earth to space. He throws the ball into a circular orbit above surface at altitude. So above some height h, he is throwing it with some speed. Right? From Earth's surface to the orbit, the change in mechanical energy. So he's taking it. So when he's taking it, they did not mention what speed he's taking. So initially you can take that the speed with which he has taken it. That speed is gradually he has moved from this place to this orbit. Okay. Here mechanical energy means kinetic plus potential. So kinetic energy at this place will be half m v square, right? He throws the ball into a circular orbit about Earth. So that means it is going in a circular orbit. This is the radius. So how much is this height? Is first of all you have to think, because radius of Earth is 6370. I think it looks like 637, half of 637, right? And 10 times. That means this height looks like r by 20. This height is r by 20. We can easily make out because 318.5 is half of 637. Extra factor of 10 is also there. So 1 by 20 times. Okay. Then height is r by 20. So radius because from center we have to take, right? So this radius you have to take, orbit radius, that become r plus r by 20. That becomes 21 by 20 r. Okay. So here half mv square, and v is root gm by r, right, whole square. Potential energy, or we can write directly the total energy. Total energy we know how to write. Mechanical energy total minus half of gmm by r, right? So this mechanical energy, which is the total mechanical energy there. The total mechanical energy is minus half gmm. Here radius is 21 r by 20. 20 r by 20. This is what it is. Now when at the surface of Earth, what were the speeds that we have to consider? Here they did not mention any speed. So we think this astronaut was taking it. There was no speed here. You can take the speed 0 at the surface. Only potential energy you take. So initially the total mechanical energy, initially, and this is finally, that is initially is minus gmm by r only. Now take the change of potential energy or total mechanical energy. Okay, so final minus initially you have to do, so change of total mechanical energy. So this will become gmm by r minus half gmm 21 r to 20, right? This becomes 10. So take LCM, 21 r, gmm can be taken common, 21 minus 10. So that means 11 gmm by 21 r. Okay, let's check the option. X we have to calculate here, the factor X we need to find out. So this X is definitely 11 here, right? This X factor is 11. That's the answer. Okay, let's move to the next. Satellite of mass 10 to the power 3 kg is revolving circular orbits of radius 2r. So a satellite is revolving around Earth. The radius of the orbit is 2r. If this is the energy supplied to satellite, it would revolve in new circular orbit. So first of all, we know the total energy or total mechanical energy is minus half gmm by r. Okay. So initially, it has some mechanical energy. Let's say that is the energy E, right? Minus half g m radius. Initially some radius it is, that is given as 2r here, right? Finally they are saying that we are adding some energy. So this energy which are there, and in that we are adding 10 to the power 4 r by 6. Now finally it will be minus gmm by some radius r. That is what we need to calculate. Okay, that radius we have to calculate. Okay, now try to calculate this. This E value is substitute, minus half gmm by 2r plus 10 to the power 6, 10 to the power 4 r by 6 minus half gmm by r. And what they have given also is capital R. G they have given. So G is gm by capital R square. This factor they have given as 10, that G value. So gm we can use as 10 R square. Okay. G into R square. So if you substitute here, so minus this become 4R. G capital M, that becomes 10 R square. Mass is 10 to the power 3. Correct? 10 to the power 4 r by 6. Again here also gm is 10 r square. Mass is 10 to the power 3. 2 r. This r is small r we have to calculate now. So 10 to the power 4 factor is going away. Right? And here r factor gone. Let's calculate. So, and this r also can be cancelled out completely, 1 r. So this is minus r by r square terms are gone, right? So minus, no, only 1 r has to be cancelled. Okay, so I think here r square factors 1 r only you can cancel here. Okay, so take out how much it is coming. So minus r by 4 plus r by 6 is equal to minus r square by 2r. 2 you can cancel, 2 3 2 2. This is r by 3 minus r by 2, right? Is minus r square by small r. Find out this value from here. This will come as minus r by 6. Correct? So minus r square by. So from here this minus get cancelled, r get cancelled. So from here small r can be written as 6 times of capital R. Right? That's the answer we are getting, 6r. Okay? Fine. So we are done with all the questions of this. Right? So I hope you have understood everything. So then we will be moving to the next chapter, properties, mechanical properties of solids. Thank you for your attention.